All right, so in this video we are going to continue our malware analysis lab. This is the third in the sequence. So we had the first one which went over, the explanation of the lab, right? Kind of what malware analysis is, dynamic malware analysis. Then the second video was how we could extract the features from the log files into the feature vector space. In this video, we now assume that we've extracted the features. We have them here in this file, log file features. We have 142 records. The dataset contains 142 instances, of which 92 should be malware and 50 should be non-malware. And from our previous feature extraction algorithm, we selected the top 1,000 most frequent terms. All right, so now we're going to proceed and take that file and do our machine learning analysis. So I'm just going to open up the Explorer. I'm going to click on Open. I'm going to select all files. I'm going to go into the desktop. And in desktop, I have log file features. I'm going to select this CSV file. I'm going to open it. And there you can see now I have all the features. So I have class name. Plus we can see once again all the features. We can also see that there's 1,001 attributes because there's 1,000 features and one label, class column. We have 142 in total. We can scroll down here and see all the feature names, see that some are words and some are numbers, as we discussed before. Obviously we need to focus on the class name here. We can see at the very top is currently indicated to be numeric. We need to change that for the machine learning algorithms to work. We're going to change it to nominal by clicking on choose, clicking on filters, on supervise, attribute, and we're going to scroll down and select numeric to nominal here. So we're going to click on numeric to nominal. All right, there it is, numeric to nominal. Now I'm going to click on the filter, and I just need to select that I want attribute 1 to be modified. So I selected 1 there. All right, I'm going to click on OK. All right, I've selected the filter, and now I'm going to just hit apply. All right, and there we go. Now when we click on class name, we go over here to the type, and it is currently set as nominal. All right, and that's what we want. We can see it's a two-class problem, -1 and 1. We can see that we have 92 samples of malware, and we have 50 instances of non-malware. We can also see it here, the distribution of the data. All right, so now that we have this, we are ready to proceed. So I'm just going to go into classify. I'm going to select a couple of classifiers. Just to show you, you can obviously try more. So I'm going to go ahead and select naive Bayes. Oh, and I need to select the class, so I'm going to go ahead and select the class here. So the class is class name. I'm going to do tenfold cross-validation, which I've described in a previous video. And so I'm just going to select, again, naive Bayes. You can see that here, naive Bayes. And then I'm going to hit Start. All right, and we're done. So now if we look at the results of the analysis, we can see that it actually does really well. Right, so the F measure is 98%, 97%, and overall it is 97%. So that tells us from our analysis, we look at precision, recall, and F measure, all values are above 90%. We can also see that there were very few misclassifications. Right, so actually our approach worked out for this simple problem. If we want to see, which attributes contributed the most, again, you can always go to select attribute, select ranker, accept that it's saying that you should use information gain, see how it changes information gain. I'm going to select the class name, and then I'm just going to do cross-validation, and I hit start, and it tells me that there were several features here. A lot of these number features don't seem to be that important. And then I go all the way to the top ranked. So you just want to analyze like the top 50 or so. Maybe as a cybersecurity professional, this might be of interest to you. All right, and so you can see that actually it assumes that for BFB, obviously the words malware and bad rabbit, if they were in there, right? And you know, sometimes that happens, right? So I've seen in Snort, for instance, some signatures, right? It says like Amanda or Pong or something, and those are keywords that identify that this is an intrusion. So same thing here, obviously. The ones that contain these words perform where, you know, these words were critical to determining if they were malware or not. And then you can see other words here that might contribute. Run DLL 32 is ranked high, and so on. All right, so this is the feature analysis, and this indicates the top features that were helpful in classifying the problem. All right, let me do one more. So I'm going to select another classifier like KNN, so IBK. The class name is already selected. Hit start, and you can see the classifier does a little bit better, it seems. If I look at, well, no, about the same. About the same. But so you can see it's an easy problem to classify. All right. And that concludes our analysis of dynamic malware, or dynamic malware analysis, or building a dynamic malware classifier with Weka. In the next video, we will look at this problem again, but now using sklearn.